Welcome back. Lesson 19, Introduction to Probability. Introduction. Probability theory was studied by mathematicians who studied the mathematics of gambling. Girolamo Cardano, an Italian mathematician from 1500s, and Blaise Pascal, a French mathematician from the 1600s, were the earliest mathematicians to start a rigorous study of probability theory. Finite probability. An experiment is a procedure that yields one of a given set of possible outcomes. The sample space of the experiment is the set of possible outcomes. An event is a subset of the sample space. Here is Laplace's definition for the probability of an event. If S is a finite, non-empty sample space of equally likely outcomes and E is an event, then the probability of E is written P of E, that is cardinality of E over cardinality of S. Since cardinality of E is between 0 and cardinality of S, we have probability of E is always between 0 and 1. Here is an example. An urn contains 3 white balls, 5 blue balls, and 4 red balls. One ball is chosen at random. What is the probability that the chosen ball is red? All right, there are 4 red balls. So the chances of that one ball being red is 4 out of total number of balls. 3 white balls, 5 blue balls, 4 red balls. So the total is 3 plus 5 plus 4, 12. So your chances of obtaining a red ball is 4 out of 12, that is 1/3. Here is another example. A pair of dice is rolled. What is the probability of getting a sum of 6? When a pair of dice, pair means 2. 2 dice are rolled, there are 36 possible outcomes. 1 on the first die, 1 on the second die. 1 on the first die, 2 on the second die. 1 on the first die, 3 on the second die, so on. Okay? So notice there are 6, 6, 6, 6, 36 in all options. We want to get a sum of 6. How do you get sum of 6? 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. These are the ways of getting sum of 6. How many ways are these? 1, 2, 3, 4, 5. So there are 5 out of 36 options of getting sum 6. So the probability that the sum is 6, probability is 5 over 36. So this is important, guys. Notice probability has to be always between 0 and 1. Probability has to be always between 0 and 1. Here, another example. In a lottery, players win a large prize when they pick 5 digits that match in correct order. A smaller prize is won if only 4 digits are matched. What's the probability of winning the large prize? What is the probability of winning the small prize? Okay, to win the large prize, we need to pick 5 digits that match in order. How many 5-digit numbers do you have? 5-digit numbers, right? So you have 5 places and each place has 10 options because there are 10 digits, right? This place could be 0 through 9. 10 options, 10 options, 10 options, 10 options, 10 options. So that is 10 to the power 5 number of numbers you have. 5-digit numbers. Now you want to choose precisely one number out of these many numbers. So the probability of winning the large prize is 1 over 10 to the power 5. But what about the small prize? Small prize you get if only 4 digits are matched. Well, you want exactly 4 digits to match out of 5 digits. out of 5 digits, exactly one has to be incorrect. So how many ways can you get incorrect one digit? Well, there are 9 ways of getting exactly one incorrect digit, because in all there are 10 digits, one out of which is correct, 9 are incorrect. So an incorrect digit may occur in the first place, or the second place, or the third place, or the fourth place, or the fifth place, because we have a 5-digit number. In other words, 5 times 9 ways of getting exactly one incorrect digit. Therefore, the probability of winning smaller prize is 45, that is 5 times 9, over 10 to the power 5, that's all possible ways of, these are the total number of numbers, 5-digit numbers. We'll reduce the 5 and one of the 10. So 10 to the power 4 times 2 and 9 is in the numerator. That's your required probability. Here is another example. In a lottery, players win a prize if they correctly guess 7 numbers from a list of 35 numbers. So they want to guess 7 out of 35 numbers. What's the probability? Well, you're choosing 7 from 35 and only one such choice is correct. So notice you're choosing 7 numbers from a list of 35. Order is not important because you're choosing 7 numbers, okay? So there are 35 choose 7 ways of choosing 7 numbers from a list of 35 numbers. Order is not important. 35 choose 7 is 35 factorial over 7 factorial times 28 factorial. When you calculate, you get this particular number. Okay. Now, the probability of choosing the correct 7 numbers. So you have to have only one correct choice, one correct collection of 7 numbers, right? Is 1 over all these possibilities. Cards. A standard deck of cards contains 52 cards. There are 13 different kinds. The kinds are 2s, 3s, so 2 of spade, 2 of club, 2 of hearts and 2 of diamonds. Those are all 2s. So that's called a kind. You could also have 4 3s, 4 4s, 4 10s, jacks, queens, kings, don't forget aces. Kind, that is also named rank, face value, denomination, and value. These are different names for kind. Suits. The suits are spades, clubs, hearts, diamonds. Okay. Find the probability that a hand of 5 cards contains 4 cards of one kind. You have a hand of 5 cards. We want to have a hand containing 4 cards of one kind. That is, we want 4 aces or 4 2s or 4 3s, etc. So there are 13 different ranks, you see, 13 from ace to king. And you want to choose 4 from 4, all right? There's only one way, so there are in all 13 different ways of getting 4 of one kind. So think about it. 4 aces you could have. That's one option. 4 2s you could have. That's another option. 4 3s you could have. Yet another option, so on. So how many options do we have? 13. 13, one for each rank. Once the 4 cards are chosen, you want to have one more card because you have a hand of 5 cards. Once the 4 cards are chosen, the remaining 1 card is drawn from the remaining 48 cards. So there are 13 times 48 ways of getting a 5 card hand with 4 cards of one kind. So this is 5 card hand, 4 cards of one kind. There are 624 ways. But what if randomly choosing 5 cards from a standard deck of cards? There are 52 choose 5 ways of doing that. That is this entire number, 52 factorial over 5 factorial, 47 factorial. So the probability that a hand of 5 cards contains 4 cards of one kind is 624 over all possible ways of drawing 5 cards. Okay, let's continue in our next video.